we're going to split up this next section into two parts as well. One for A, we're going over how to find an inverse and graphing them and determining if they are functions. An inverse. It is when the x and y trade places. So it's just the trading places of your x and y, and you solve it for y again and graph it. So if you're given a list of a table of values or a list of points, it's really kind of nice because all you have to do is trade places, literally. Your x's become your y's, and your y's become your x's. You're going to call them x, y, but what was your x's is now your y's. And what were your y's are now your x's. So what was the point -1, 7 is now the point 1, or 7, -1. What was the point 2, 4 is now the point 4, 2. And so forth. If you were to graph these on a graph, you could actually fold the line of y equals x, and you'll be able to have the points match up. For the second problem, we are going to actually find what is the inverse. And the inverse is usually noted by saying this little exponent of -1 after the function. That's how you know they're talking about an inverse. So if you ever see the -1 exponent after your function name, between it and your variable, that's when they're talking about the inverse. So let's solve through f of x is equal to 4x minus 7. Step 1, just write down the problem. I usually like to replace my f of x with just a y. It makes it easier to solve for the next part. And so now what I told you inverses were when x and y traded places. So I'm just going to trade places with my variables x and y. And I am going to solve for y. So to solve for y, I need to get y alone. I am going to add 7 to both sides. X plus 7 cannot combine, so I am left with x plus 7 equals 4y. Next, I am going to divide both sides by 4. 4 will not divide evenly into both x and the 7, so my final answer is simply x plus 7 divided by 4 is equal to y. Now, that's not in that inverse function notation. Just to rewrite it, you're to do f of -1, or to the -1 power of x is equal to x plus 7 divided by 4. For example 3, we are going to graph x squared minus 2 and its inverse. Also, the question asks, is f of x a function? So to graph x squared minus 2, I can use the graphing utility in my calculator, Or if I want to, I can do a table of values. I'm going to show a table of values here, x, y. I'm going to do negative 2. So negative 2 squared is 4 minus 2, 2. Negative 1. Negative 1 squared is 1 minus 2, negative 1. 0. 0 squared minus 2 is negative 2. 1. 1 squared minus 2 is going to give me a negative 1. Positive 2. 2 squared is 4, minus 2 is 2. And so I can graph that function, and I graphed it here in red. So one way to graph the inverse would be simply just to switch the places around and then graph a set of points, which would invent, if I continued on, the trend would show me this. Or I can figure out what f of negative 1 of x is. Basically, I can find the inverse. So let's practice finding the inverse. I'm going to go ahead and do that here in purple. So, like I said, I like to rewrite this as y, so I'm just going to go ahead and do that from the get-go. Y equals x squared minus 2. So when I solve for x, I need to add 2 to both sides. Oh, excuse me, not solve for x. I need to switch places. X comes over here, y comes over here, and I'm going to solve for y. So I'm going to add 2 to both sides. And that gives me x plus 2 is equal to y squared. Now to undo a square, I would need to take the square root. To undo a third root, or a third power, or a cube, I would need to take the cube root. To undo the 10th power, I would need to take the 10th root. So I'm saying all those because on the homework it may not be a square that you're undoing. So I'm going to take the square root of both sides. So y is equal to the square root of x plus 2. Well, that doesn't really cover all of it. When you take a square root or an even root, you always have to include a plus or minus in front. Anytime you take a square root, fourth root, 6th root, 8th root, 10th root, any of the even roots, you must include this plus or minus. Otherwise, when you graph it, you'll only get half a graph. And a good way to test that is actually to go in and test what would it look like to graph just the positive square root. And if you did that, you would come up with just this portion here. Now the last part of the question asks me, is this a function? So is the inverse a function? If I do the vertical line test, would it pass the vertical line test? Well, as you see, as I'm drawing a few vertical lines here, it is failing at almost every single point. The only point it's not going to fail is at the vertex. It's only going to go through once. So it is not a function. It is just a relation. So, if you're having to solve an equation for the inverse, step 1 is to change x and y's place. Step 2 is solve for y.